Hello, everyone. Welcome to our talk. We'll be talking about benchmarking and some other stuff. So, hi, my name is Iury. I'm working with mobile stuff at Klarna. I'm currently building a browser, basically, and I love building tools and hiking, cycling, and nerding out about functional programming. This is
And this is Enrique. I'm Android Kotlin Mujidi. I'm the maintainer of the Kotlin Weekly. If you haven't subscribed yet, please do it. This is my Twitter handle. And besides programming, I like running and finance, but I didn't make it to create a career out of it. Now, into benchmarking. So we have a definition that we found on the Wikipedia and says that the benchmarking is the practice of comparing business processes and performance metrics to industry best and best practices from other companies. And things that we typically measure are quality, time, and cost. But this is Detroit con Vietnam. So a bit more of a Android-specific definition would be that benchmarking is a way for us to test the performance of our application. We can regularly run benchmarks to analyze and debug performance issues that can be happening and make sure that we are not introducing regression in changes that we are doing on our app. Then we also have another relevant topic, which is profiling. Profiling in software engineering, it's a mechanism to analyze things like space or memory in an app, time complexity, usage of particular instructions, frequency, or when certain functions calls are happening. So in the Android benchmarking world, we have actually like three SDKs that we will be using. One of them is the micro benchmark, the other one is the macro benchmark, and then JankStats, which is a recently released framework from Google. Then profiling. In Android, we will be using the Android profiler. Since Android Studio 3.0 is integrated in the IDE, it replaces the old Android monitor tools, AMT. And we have a CPU, memory, network, and energy profiler. So the idea is that by using these, we can identify bottlenecks. We can find issues that might be arising with our apps, like a lot of energy consumption, a lot of memory consumption, the device is getting slower with the app, etc. So I guess you've opened this at some point in your life. So we have this panel that integrates the memory, the network, and the energy profiler. We can see that at the top on the number one, we can see the process and device that we are currently profiling. Then in the sessions, we can actually choose one of the running sessions, and well, this would be the general one. We have this big panel that moves over time and includes the energy consumption, network, and memory. And we have on the point number 3 some icons to make like zoom in, zoom out, and be able to move through this slide. Particularly the memory one would be this one from here. We see that we have different graphs based on whether this would be the one for memory, whether this is code or native memory or Java or graphics or whatever. We have a button which is the number 1, which forces garbage collection event. So it sort of freezes the memory consumption at that time, takes a picture, a snapshot, and allows us to see in this screen from here what's the memory allocation. So which objects we have created and we have in memory, the allocation call stack, which functions are being called on our stack, etc. And then last we have the energy profiling. So we have on the timeline as well how the transition has been working on the app through different life cycle, how the energy is being consumed at some point. And we have also code of color to see whether that's coming from the CPU or network or whatever. Now, micro benchmarking. So micro comes from I think it's the Greek small, and well, it serves us to execute benchmarks on our Android native code from within Android Studio. We should actually profile the code before writing benchmarks. The idea is that we can identify where problems are happening, we can see those bottlenecks, and then we can do a bit more of a smart micro benchmarking instead of just writing benchmarks without any scientific base. So it's useful for CPU work that will be running many times on our app. And some examples can be recycler view scrolling with one item being shown at a given time, data conversions or processing, or whether we need to apply any algorithm to transform data, etc. If we want to use it, we would add the following line as a dependency to our Gradle file, and then we would start writing our benchmark. So
if you see this one from here, it's similar to how we write tests, right? We can even see the run width and the Android unit annotation at the top. And those are the key components. We will have a rule. So see that we are creating this benchmark rule. And then in our test or our benchmark, we will call the function measure repeat and then execute some work. This is the generic version. See that the micro benchmark will run directly in the code, so we need to place the code we want to benchmark in a separate Gradle module, as you can see here. Similar to test, right? We can have like a different place that where our tests don't get shipped with the app is similar to the benchmarks. Now let's see something that more similar to or what we would see on the real world. So this would be a benchmark that, we have an array of items, we sort them, and we want to identify how fast this process is happening. So here at the top, we will have the random function. Then we will have an array of unsorted items that we create using the random functionality. And then we will have this test function that takes the, you can see here, the benchmark rule.measureRepeat. Here we start sorting the algorithms. We call the quick sort whatever. This is going to take some time, from the interviews of those fun companies that they ask you to create code the quick sort algorithm. And we will be measuring this and getting some results. We can actually run the benchmarks using this Gradle command from here. At the top, we will be running all of them with benchmark $connected check, or we can run the specific ones. This is usually if you have a CI/CD and you want to execute only a family of benchmarks or numbers of them, or run all of them. You can choose it with the following argument. If you do this from the IDE, you're going to see this result here. You see that, we see the name of the benchmark, so build paragraph or scroll or whatever we want. And we are going to see the amount of time that it takes to finish this benchmark. This is different from tests. Tests are deterministic, as in a test can fail or pass, but a benchmark doesn't pass or fail. A benchmark is going to take an amount of time given some circumstances, and that's where Iury will explain later. How can we identify regressions or see whether the benchmark is getting worse over time or better over time? Micro benchmarks are similar, but they are used to test larger use cases of the app. So typically things like the application startup, whether we want to make complex UI manipulations or running animations. We need to make the app profilable for that. We do it by adding this annotation here to the manifest. We will need to configure our benchmark. So in our Gradle file, we will need to add this benchmark block here at the bottom that you see for a given configuration. So typically, you want to do this on release if you want to test the real app that is being deployed actually to the users, or you might have a use case where you want to do it on the debug app, whatever. We need to choose on the IDE, again, the benchmark build variant. When we have added this block to our build Gradle file, this will be available. So you go to View, Build Types, select the specific benchmark, and then it will be running. So this is an example of a macro benchmark. It's similar, actually, to the micro benchmark. You see that we need to, we're adding the large test notation, because they're typically are going to be larger than the micro ones. Then we will have a rule here. See that in this case, we don't have a benchmark rule, but we have a macro benchmark rule, which has different methods and a different mechanism. And we will have our test/benchmark function that runs. We're calling, again, the measure repeat. And see that here, this is a little bit different from the one we saw before. Here, we're going to specify the package name, iterations, etc. And the important one is the metrics. So here we see that we're passing a list of metrics that each of them contain different arguments. And then at the end, we have a lambda where we start our activity and wait if we want to measure, in this specific case, the startup time. Metrics we have. Right now we have 3 of them. A startup timing metric, which captures the app startup time and everything that is happening there. The frame timing metric, which captures timing information from frames that are being produced by a benchmark, such as scrolling or animation. And then the trace section metric, which is still experimental and captures the time taken by a trace section. And yeah, again, we'll see here the results. So you can see that we have run time of full display milliseconds, time to initial display milliseconds, and then we're able to see exactly the values that are coming. Also see that here is different from the one that we saw before. We don't have just the time that it takes to run the benchmark, but here we have a minimum one, a median one, a maximum one, and we can run different iterations to make sure that, well, we're within a given range of values. So we see that we have this result here on the IDE. This is actually also being posted on Logcat, and we also produce a JSON file. This is interesting if we want to keep a track and a history of how our benchmarks are happening and the value they are displaying. Later, those files can be integrated with our CI/CD, and we can analyze, OK, for this specific benchmark, we can see that the maximum value is increasing or the median value is decreasing, and based on that, they identify regressions. And JankStats. JankStats is the newest framework from Google. It was released on the 9th of February 2022. I was at that time preparing a call with Iury on the 10th. And then the night before this happened, and we have like sort of redo a few things. It's built at the top of Android, and it's an in-app benchmark. So this is not anymore happening in a different module, in the separate files. This is actually happening within the app itself. And it's alpha at the moment. So this would be an example of using JankStats. You see that here is where the magic is happening. We would need to create this metrics state holder, and then we will create the JankStats objects within the application itself. You see that this is an activity extending from the app compat activity, so it's happening within the app. We have a reporting mechanism. The reporting mechanism happens through this listener from here. We see that when we create this listener, we have the frame data value, and then we could use it to log anything. In this case, it's a sample one. In an interesting app, we will be doing things like writing in local storage or whatever we want to do. And the frame data that you see here coming from the on-frame listener contains those values from here. The frame star, nanoseconds, frame duration, nanos, and then a Boolean called isJank. This is heuristically determined by the library to see whether this falls in the definition of Jank or not. There is full documentation that explains how this heuristic happens and how Google determines whether you're actually handling Jank or not. And we have as well an aggregating mechanism. So we see now here in this activity something similar to what we saw on the other one, but can you identify any difference? Yes, very right. I found this annoying GIF to point out. So now we're just not using the JankStat class anymore. Now we have an aggregator, right? What's the difference with this aggregator? Well, this aggregator allows us to proactively determine where those things are going to be reported. So when are we going to create the JSON file and save everything? Here you see that in onResume, we will enable the tracking, and in onPause, we will disable the tracking, which is a good idea if you're shipping this application to production, right? And before we actually deactivate it, you see that we're calling the function issue Jank report that actually starts the reporting mechanism. So it doesn't happen every time. We have control on when this is happening. This is similar if you have worked with analytics libraries. They work on a similar way, right? They are not all the time reporting the analytics, because that would have a high consumption in terms of network, because maybe you have like a small thing, you don't want to upload it, you just want to aggregate a few kilobytes or megabytes or a few different metrics, a few different analytics, and then upload them. And now that you know the underlying mechanisms, Iury is going to explain you how we can find actually regressions in CI.
Right. So yeah, now is the point that we check how to detect regressions in CI. So first, what is CI? Just to clarify that everybody's in the same page. So this is the definition of CI, but as most of you guys probably know, is that actually it's that thing that prevents you from merging your code, right? So those checks that you have to run. And regression from the dictionary is this return to a former or less developed state, but for our scenario, it's actually we're talking about performance degradation. So you may be thinking, why would you need this in the first place, right? So why would you need to detect regressions on your CI? To understand that, just let's go a little bit over to what's normal scenario on your day-to-day life may look like when you get a regression. So you're probably working on something. Another team shows up, usually a QA, and they warn you about a critical performance issue that your app may be having. So then you need to switch context, then you need to try to investigate, try to understand what's going on. And that's usually leads to a lot of pain, right? Because you have to do a bunch of manual profiling, benchmarking, just manually doing stuff. So you want to improve on that. So how can we do that? One way to do that is basically to monitor performance instead of having to profile every time. So if you have a mechanism that you can just lay there and it's going to warn you when something goes wrong, it's better than a team or someone warning you. So this will allow you to catch issues before they hit the end user. Because maybe most companies already have some kind of mechanism implemented with analytics, and you're kind of using analytics data from users to understand when something is going wrong, right? But at the point that this happens, this already means that someone's having a bad day because of performance issues, right? So you're getting data from users to identify that you're having performance issues. So with this approach here, we can try to identify this before they hit the user. Also running benchmarks manually, repetitive, error-prone, all that kind of stuff. No one else likes to do that. Also, like Enrique mentioned, when running benchmarks, like macro benchmark or micro benchmark, the output is just a number. It's just a scalar value. It's not like a test which tells you like, oh, this is failing. The output of benchmark is not that. So when trying to detect regressions in CI, we also want to improve on that and have to try to create a way to identify that automatically. So, like I said, ideally we should automate this process. And this is from Kurzgesagt. We want to use machines to do what they're best at, right? So how can we do that? So let's go over a basic example of that. Maybe we want to monitor degradation in app startup time. So like Enrique was mentioning, we can use the macro benchmark library for that. It has this startup timing metric, so you can take advantage of that and try to use it. So I'm going to go like what it looks like to use this app or this library. First thing you have to do, you have to install the artifacts, right? So you have to basically install the APK or the executable app on your device. And this thing there with the other icon, that's actually not true. It's this macro benchmark instrumentation. There is no name for that. I just came up with that because I needed an icon. But what you got to understand here is that first you're going to have your app, and you're going to have this macro benchmark thing also installed on your device. So you can think about it just like a Puppet, which is your app, and a puppeteer, which is the macro benchmark thing. So this guy is going to control your app and try to impersonate your user, a user. So this is just so you understand that this is not installed in the same bundle, and this is isolated. So in a way that you can kind of trust the data, the output, the benchmarking data more than other frameworks. Right. So first step, you install. Second step, you run the macro benchmarks tests. So this, like Enrique showed, this is going to be your output, right? So you're going to have this benchmark data.json. So everything is there. There's a bunch of information there about the runs, the median time, the maximum value, all that kind of stuff. And right, so you install, you run, and then you have to store this result, right? So you have to store this data. So this is the basic setup. So first you have to think when you're going to run this. So there's a bunch of ways you could do that, right? So you could run this on every build, but if you're running on every build, maybe you have to be aware of the resource cost of that, because that's going to happen on your CI. That's going to take some time, resources, and all that. But maybe you can run this on every release of your app or every 10 builds of your app. This is up to you to decide with your team what makes sense to you. Besides that, you need to think about where you're going to run this. So ideally, it's a recommendation from Google. Ideally, you want to run this on real devices, basically because they're more real. They're going to give you better data, more reliable data. And you could use something like Firebase Test Lab for that. So you have like some kind of a device farm, so you can offload this too. And also you have to think about what to store. So in our case, we're going to be storing these performance metrics, this time in milliseconds. This is what we are actually interested about. And you also need to store the corresponding build value to that benchmark. So in one hand, you have the milliseconds value of your benchmark. In our case, it's about startup time. So you have that startup time, and you have a build or a commit hash ID, something to relate to. So you have these two pieces of information, right? So this is the basic setup. Now what, right? So now it's the detection part. So there are multiple approaches for that. And we're going to go from the basics to the more advanced or smarter ones. So this is the basic one, right? So you have the current build startup, and you have the last build startup. If the current is bigger than the last, then it's a regression, right? Simple enough. Except that you shouldn't do this because, as you might be thinking, benchmarking values, they're not really stable, or you can think about them as a really flaky test. The data is going to vary quite a lot. Even if you're using Google's libraries, like macro benchmark, if you're using that, you're going to read on the documentation that it's actually isolating your app. It's doing it in a way that the values are not going to jump that much, but it's still not perfect. They still vary quite a lot. So why that happens is basically you just can think about that you cannot control what's going on the device at any moment. So lots of things can happen. If you have a device farm, you can think about, I have no idea what the device is doing when you ask it to run the task, right? So basically a lot of things can change, and you don't have control of that. So what we want to try to achieve with this regression thing is trying to improve on that, right? So if you can't really control the data or the device and what it's doing, then we have to find a way to protect ourselves from basically false positives, right? So another approach, so that's the most basic approach, right? So this is another one. You can use a threshold value. So you can imagine, okay, I'm running my benchmarks, and I'm noticing that there's a variability of 5%. So I'm going to go ahead and set 10% as a threshold, right? So if the values jump bigger than 10%, or then I'm going to consider a regression. So let's go with the basic example of that. So imagine you have this kind of data. On the bottom, you have like build number. On the vertical line, you have the time. So it's your startup time is like 1.5 seconds. And it's varying around that line. So if this happens, is this a regression, right? So according to what we just said, this would be a regression, right? We had a spike. It looks like a regression now because it's way above what the others were. But what happens is this shows up right after it. So that was a false positive, right? So how can we prevent these kind of things? This kind of approach, let's just go over with the problems with it. Since the values are really inconsistent, this is going to trigger false alerts. So you're going to be thinking that something is a regression when it's not. And the other problem is you may be missing real regressions, because if you set a threshold of 10%, then you're missing 8%. So a regression of 8% is just going to fly under your radar, basically. So you can think that we can probably do something better than that. So let's set our constraints for what the ideal solution for that would be. We want to handle this temporary instability. We don't want to manual tune every benchmark. So you don't want to be changing your threshold every now and then. And we want some kind of accuracy, right? So now, instead of saying maybe that now comes the detection part, I should have said that now comes the math part, because we can do something about that, and it's probably going to use some math. Right, so what we need to understand here is that we need more context to make this decision, right? So you cannot just be looking to your immediate past to understand if something is a regression. You may be wondering, what does that actually mean? Right, so there's this algorithm called step fitting. It's this statistical approach for detecting jumps in a time series. So as this is directly from Wikipedia, this chart. So you can just see that something happened there, and that it's actually a step. And if you normalize this data, you can clearly see, but if you're not looking at the whole thing, you just see a bunch of numbers jumping up, right? So we want to kind of use that picture, put it on top of our data and see that clearly. So I know it's at the end of the day, it's been a long day, everybody's been watching talks the whole time, so I'm going to give you basically a basic intuition of the algorithm. I'm not gonna go into detail. If you take a look at it, it's about like 20 lines of code. It looks something like out of lead code, you know, it's a sliding window. But let's not go into detail, so I'm just gonna give you the basic intuition, right? So the main objective is to increase our confidence in detecting these regressions, right? So we're going to basically have a sliding window that's going to help you make context-aware decisions. And the context is coming from the window, right? So you're going to put a window on top of the data, and you're going to compare the build benchmark value with the average of the window. Not really the average. There's a bit of math happening there, but it's basically that. And yeah, basically you're going to check it's on the slide. You're going to check the build benchmark values inside the window, so you're going to have a width and you're going to have a threshold. And there's more graphic data here that's going to help. Right, so imagine you have this time series with these build values, with these benchmark values, and another piece of data comes up, right? So you want to understand if this is actually a regression or not. So what we're gonna do here is that you're going to create this sliding window on top. So it's basically two parts. So it's like a width to the side, a width to the other. The sliding windows is the two things together. And the green arrow is actually pointing to the one we're comparing to. So we're going to be comparing that piece of data, that benchmarking data, with the whole window, basically. So that's your context. And as more data comes in, you keep moving the sliding window across and checking that other piece of data with the rest of the window. So, and you keep running the step fitting algorithm. And as more data comes in, then you're going to be more certain when something like this happens. So this is a really obvious one. Maybe I should not pick a really obvious one, but it gives you the basic intuition. This would also identify if it wasn't that obvious, you know, right? So because if you take a look, all right, okay, it pretty much looks like a regression, but yeah. So this is the basic intuition. So to recap, we want to detect regressions in CI. We want to automate this regression detection on key points of your app. So you can think about it like, I think like startup time is a pretty hot one. You may have been involved in a project where you had to help to reduce startup time for the app because the people suddenly realize that it's not ideal, and then there's a big effort to reduce app startup time. this would avoid this kind of issues, right? So you just have it set up in a way that if something happens, and this is critical, it's not in those slides, let me see. Yeah, it should be there. You're going to want to have an alert fired. And you're going to have an alert fired if that's a regression or if it's improvement. Because if you have a huge improvement, you should also be aware, right? You should also be take a look at it, like, because it doesn't, like, it shouldn't, it's not normal, right? So you have a huge improvement in apps performance for out of nowhere. It's also fishy. So this is going to help you to catch issues before they hit the users, and yeah, that's about it. And
then a recap of the libraries that we mentioned. So we have the Jetpack benchmark family, which include micro and macro benchmarks, and is run in instrumentation test as benchmark, similar as to how we run test or UI test. And then JankStats that should be used on real devices when possible. It contains a reporting mechanism and is the latest benchmark library from Google, and still alpha, as mentioned. So keep it in mind based on the versioning policy you're using at your company. And we should be using profiling, the profiling tools that Android provide us to be able to identify memory, energy, network, or CPU bottlenecks, and be able to come up with a smart strategy for our benchmarks. Some resources, there is this first article by Chris Craig from Google, where he explains how they implement their benchmarks at the Android OSP. They actually provide like real data. They show real examples on issues that they have identified on while they were developing Android, and how they implemented actually or I think they have a link to a Kotlin Lang website where they saw an implementation as well of the step fit algorithm. Of course, the benchmark official docs, and then the JankStats library, which is an independent one. Last but not least, you can, on the second link, you can download the slides if you want. And on the first link, we have a small form, 1 minute for feedback. So if... Yeah, the QR code is the link at the top. So if you have a few minutes that you can spare, then you can give us your feedback. We would really appreciate it and use it to improve our presentation. So thank you so much. It's been a pleasure to be here in San Francisco after a pandemic. Those are our Twitter handles if you're interested in following us. And if you have any question and we happen to know the answer to that question, we would be super happy to help you.